Spherical mirrors. A spherical mirror is a curved mirror which has the shape of a piece that is cut out of a spherical surface. So it's a curved mirror. What does it mean? Well, this is a plane mirror, right? Wherein you have a plain glass that we use pretty much daily. Curved mirrors are not plane, basically. They're curved, as simple as that. So a spherical mirror is a curved mirror which has the shape of a piece that is cut out of a spherical surface. Let me explain this. So this is your plane mirror and the opposite is your spherical mirrors. So I have a sphere. If I happen to cut at one end, you know, take take a shot, cut it across some this and that end doesn't matter. So if I happen to cut at one end, we end up with something like this, right? If the sphere happened to be hollow, is it not? Right? If this sphere happened to be hollow, if we cut it out, you'll get a shape like this. Make sense? I will give another perspective. So if this is your sphere, right? If I happen to cut out, I'll end up with only this, is it not? Something like this. And you'll end up with a mirror which looks like this. It's not plane, obviously. It is curved in. So clearly, this is curved in, right? I'll give you guys a second or two to have a look at it. Or we can term it as it's a mirror which is curved out, right? Something like this. So it's bulged out. If I take a mirror and push it and say that is a mirror, that mirror happens to be flexible, I can get a mirror which is something like this. Or if I take a plain mirror and push it in, so the reflecting surface can be this. Okay, so this is an example of a curved mirror, right? So basically, I won't be able to draw it, at least not as good as this. So let me copy it off. So this is a curved mirror. Okay, a spherical mirror basically. Since it's a part of a sphere, that's why it's called a spherical mirror. Make sense? Okay, now there are two types of spherical mirrors. One is concave, another is convex. So what does it mean? Well, if I happen to take the sphere and cut it across and get this part, and if I happen to, how do you put it? Put the silver cover back of this. So basically, this is your reflecting surface. I'm looking at the reflecting part of the surface. If this part is your reflecting part of the surface, okay, while this is, put with this silver paper and all of that, that is, if you stand over here, you won't be able to look at yourself. Here, you'll be able to look at your reflection. Such a scenario is your concave mirror. Okay, I'll give you examples so that you guys will get to understand exactly. And convex is opposite of this. That is, if I happen to stand in front of this part of the mirror, okay, and I'm able to see myself. This is an example of convex mirror, right? So basically, this will be your shaded part. So there are quite a few differences. I'll be listing them. So here you won't be able to see yourself. Okay, so this is your basic spherical mirrors. So now the official definition of concave mirror is this: a spherical mirror whose, right, it's part of a sphere, is it not? That's why it's called as a spherical mirror, whose reflecting surface is curved inward, right? You can see clearly it is curved inward. that is faces towards the center of the sphere is called as a concave mirror. I'll explain this part. Faces towards the center of the sphere. So you can clearly see this part of the sphere is not facing the center of the sphere. This is facing the center of the sphere. This is your center of the sphere. This particular dot is the center of the sphere. If this was the reflecting surface is facing the center of the sphere. That's what they mean. Okay, please have a look. Okay, does that make sense? The reflecting surface is pointing towards the center of the sphere, imaginary sphere. While convex mirror is opposite of this. That's it. A spherical mirror whose reflecting surface is curved outward is called a convex mirror. Here, the center of the sphere will be back of it. So here is where I stand and look at myself. Over here is where I stand and I look at myself. This is your reflecting surface. And the dot or the center of this imaginary sphere is in front of the reflecting surface. And in this case, the reflecting surface is this, while the center is back of it. Okay, so I want to practically show you guys that the caved in and caved out. So you guys can have a look at this video. Okay, so a small question to you guys. Which of these two, right? Let's say this is the photo from that video. Which of these two is your concave and convex mirror? One of it is concave, another one is convex. So which is that? Which is what? And give reason as well. Of course, I can't hear you guys. But yes, I would like you guys to be honest to yourself. So which is your concave and which is your convex? So to figure it out, I took bunch of ball bearings. I left it at different places. Maybe somewhere over here. I forgot where I left. Maybe here, something like this. So in this mirror, it stayed in the center. Even though I left it at the corner, it came back to the center. In this, even though I left it at the center, it is running away. You can clearly see it's running away. Right? So this is caved in. Only because of that, it's staying at the center. This is caved out. Okay, it's bulged at the center. So that's your concave. Yeah, this is your concave and this is your convex. Okay, so that's how you guys can differentiate it. And yes, we'll be understanding and using concave and convex, and we'll be performing few of the practicals as well. So you have this two in detail, right? So this was a small introduction. Pause and copy pretty much all of it. Whatever you guys can draw, try to do it. If you guys want to make a running note, so you can do so.